Hello and welcome to this R tutorial. In the previous tutorial we took care of all the data preprocessing and we made our dataset ready for multiple linear regression. So today in this tutorial we are ready to fit multiple linear regression to the training set, and that's what we're going to do right now. So as for simple linear regression, the first thing that we're going to do is to introduce the multiple linear regressor, and we're going to call it regressor. So that's the common approach to make a regression model. You'll see that we will create each time a regressor that we will fit to the training set and then apply the predict function on it to make predictions, to make the predictions of new observations like the test set observations. And then as for simple linear regression, we're going to use the LM function, here LM, and in parentheses we're going to input the parameters. Okay, so let's have a look at the LM function here by pressing F1. Here we go, fitting linear models. Let's look at our arguments. So that's the same as for simple linear regression actually. The first argument is formula, but this time you're going to see how we will need to change the formula syntax. For those of you who don't already know the trick, I'll give you the super trick to write the formula very quickly. And then the second compulsory argument to import is the data. And of course it's going to be the training set. So let's first input the formula. So formula here. So remember in simple linear regression, we wrote the formula salary proportional to years experience. And here it's almost going to be the same. But the difference is that we have several independent variables. We have 4 independent variables. In simple linear regression, the dependent variable was proportional to the only independent variable. Well, here it's going to be the same. The profit is going to be proportional to these independent variables. Only the correct way to say it is not proportional, but is the profit is going to be a linear combination of the independent variables. And formula equals profit alt n. And here the idea is to add all the independent variables separated with a plus sign. So let's look at them. It's RD spend. I'm using the dot here because in the dataset we have some spaces and R replaced them by dots. So here it's dot, then plus, and then the other variable, which is administration, plus marketing spend, plus state, and that's all. So that's how you express the profit as a linear combination of all these independent variables. That's exactly what means this formula. However, there is a trick to write this formula in a much more efficient way. It's instead of writing all the independent variables here, we can simply write a dot. That's what we can simply write, and that's the exact same equation. R understands that you want to express the profit as a linear combination of all the independent variables. So the dot here just means all the independent variables. Okay, so that's for the first argument, formula equals profit as a linear combination of all the independent variables. And the second argument is data, and as we said, it is of course the training set, because we want to train our multiple linear regression model on the training set and then test the performance on the test set later. Alright, so that's it for building our multiple linear regression regressor. So we're going to select this and execute. Here we go. And now there is something very important to do. And this is something very practical, very useful in R. It's that we are going to look at the informations of our regressor that we just built here. And to do this, it's really simple. We just need to, it's actually like simple linear regression, only here this time it's going to be more interesting because we will have several independent variables and some of them will have a stronger effect on the dependent variable. So we'll see, it's going to be more interesting. And so like in simple linear regression, we're going to write summary of our regressor. All right, and just press enter. And that's it. I'm just going to move that up. And here we have all the info of our regressor. Okay, so here the first thing is just a reminder of what the formula is. So the profit is expressed as a linear combination of all the independent variables, and our regressor is trained on the training set. Okay, perfect. Residuals, we will be talking about that at the end of this part. So let's not focus on that right now. However, that's the important part, the coefficients here. That's what we need to focus on right now. Because as you can see, it gives some info for each of your independent variable. Oh, by the way, state 2 and state 3 here are the dummy variables. And that's because, I told you that the library takes care of everything for you. Not only it created the dummy variables, R knew that it had to create dummy variables for the state variable, and we helped R to understand that because we encoded the state variable as factors. So R did all the job for you because not only he created the dummy variables for the state variable, but also R didn't fall into the dummy variable trap because, as you can see, it automatically removed one of the dummy variable to avoid some redundant dependency. So that's perfect. That's the beauty of R libraries as well as Python libraries. In Python, I know we specified a new section to remove the dummy variable, but that was just to remind you about the trap. We don't need to do it. R and Python take care of that for you. So that's great. That's the first thing to notice. And then what I was telling you is that for each of the coefficient, we have different information. We have actually the coefficient in the linear regression equation. Then we have the standard error, then the t-value, then the p-value here, and then the significance level. So the most important info by looking at this are the last two columns, the p-value and the significance level. Because these columns tell us about the statistical significance of the independent variable onto the dependent variable. That means it tells us if each of the independent variable has a significant impact on the dependent variable. Okay, so let me first explain what the p-value is. The most important thing to understand is that the lower the p-value is and the most statistically significant your independent variable is going to be. That means that the lower the p-value is, the more impact or effect your independent variable is going to have on the dependent variable. And generally a good threshold to use is the 5% threshold. That means that if your p-value is lower than 5%, then that means that your independent variable would be highly statistically significant, and the more it is above 5%, the less it will be statistically significant. So that's how you must interpret the p-value. And then we have this last column, which is just a faster way of interpreting the coefficients. Because as you can see, we have this line here that explains us about the stars. And basically what the stars means is that when the p-value is between 0 and 0.1%, then there's going to be 3 stars, which means a highly statistical significance of your independent variable. If the p-value is between 0.1% and 1%, then it's a quite high level of statistical significance. Then if your p-value is between 1% and 5%, then the independent variable is still statistically significant, but will have a less strong effect than the first categories. And then if your p-value is between 5% and 10%, it's borderline. The independent variable might have a certain level of statistical significance, but not that much. Anyway, a lot less than those independent variables that have 3 stars or 2 stars. And then if your p-value is between 10% and 1, then there is absolutely no statistical significance. That means that your independent variable won't have any effect on the dependent variable. So that's very interesting because when we look at our independent variables here, we notice that only one variable has a high statistical significance onto the dependent variable. It's the R&D spend. So it looks like the profit is mainly governed by the R&D spend. That means that it's the R&D spend that has the only strong effect on the profit. So that's a very important information for our investors because they now know that they shouldn't only be looking at the profit itself by, just looking at the maximum profit to decide where to invest, but also it should be looking at the R&D spend variable. It should be looking at the amount spent in R&D to add another criterion in their investment decisions. So that's a very good info. And basically what all this means is that among all the independent variables here, the only strong predictor of the profit is the R&D spend. The rest is absolutely unuseful. So actually what this means is that we could rewrite this multiple linear regression equation and turn it into a simple linear regression, because since the only independent variable that has an effect on the profit dependent variable is the R&D spend, then the formula could be profit equals R.D.spend. And that would be okay. That would actually give us the same prediction. Okay, so you learned a lot of stuff in this tutorial, but that's very important things to know in linear regression. So congratulations. We only have one tutorial left where we will be predicting the test set results. So I look forward to seeing you there, and until then, enjoy machine learning.